How's it going, everyone? Welcome to another video. Eulier Gonzalez here. Right now we're gonna recap about the Redux fundamentals as a way to then move on the Redux advanced topic, or the advanced course, which is looking at the RTK Advanced Redux Development Toolkits, and what are the problems that they are solving, or that such library is solving. And well, because right now the idea is for in today's video is not only look at the Redux fundamental in the theory, but also to be able to describe what are the problems that this particular library is, the solution that this particular library is bringing to the table, but have a more practical understanding of what are the problems that it solves. So that is today's video. And that is, yesterday we looked at how can we create, yesterday we looked at how can we define is the Redux, right? So according to Mark, which is the maintainer of Redux, all right, on his blog, let me actually see. Exactly, so we got Redux here, the Tao of Redux, all right. So as a way to understand what are the Redux goals and influence, and also the designs and intentions and intents, this is something important, especially for senior developers, right? So anytime that you saw a particular tool out there, so anytime you see a particular, anytime you see the new you see the new hot coming frameworks or tools that a lot of people are actually using, ask yourself, what is the goal and the influence of these particular tools? What is the design principles and the intent, right? To put it short, what is the problem that they try to solve and how they do that? So because maintaining states in applications is something that back in the old days we have now the server that was responsible to do that, to do all the heavy load, right? And now with the advancement on technology in mobile devices or in all of these end devices, so now they have much more CPU and memory and hardware resource. So their hardware resource has been improved over the couple years and decades. So now the developers at this top tech company, one of them is Facebook, as well as eBay, which is something that few people actually mention, but yes. So the first generation of this top tech company, like eBay, PayPal, and Amazon, and now the second generation from 2000, where you have is Facebook, for example. So all of this company, what they did is just to recognize that there are problems when it comes to develop UI, user interface, and also they want to deliver the best experience to the user. What does it mean is that they want to now avoid or make the round trip, which is the way of how you click on, so in a website you click here and then you have to wait for the server to be render the HTML and then send that. So this is known as the round trip, okay? But the idea here is to say, hey, we want is to now send all the necessary send only the necessary data to the browser, and that is what is known as the client-side rendering. So we're gonna let now the browser actually, we're gonna delegate to the browser that do all the heavy lifting as well. While now the server can focus is, instead of pre-rendering HTML elements, right? It can focus now is on sending the necessary data, sending JSONs, for example. However, the things here is that sometimes you will need to have client-side rendering applications and server-side rendering application. There are the use cases. So for client-side applications, you can use that when the SEO is not important. So for back office applications or admin dashboards and games, when you don't care about that website actually being ranked for search engines or for the web crawlers, all right? But if you care about that, so for example in blogs or news websites or e-commerce and that kind of thing, then you need to actually server rendering on the server-side rendering. And there are some now hybrid rendering modes, such as hide rotations or stale while revalidate, incremental incremental rendering, incremental rendering. So all of this, okay, is just as a way to improve the user experience as much as possible. So because now we're delegating the state of our applications to the client, we need to find a way to make that state maintainable. And we know when mutations to those states happens, because JavaScript doesn't have this inherent mechanism of knowing how to do that. All right, so mutations that you make to your objects or to your data are done, so you don't have some sort of tracking mechanism to know what's going on. All right, that's why, for example, here when you're creating your client-side applications or server-side applications, Redux come up and say, hey, let's go to now follow the Flux architecture, which is a way of how you can now is update an state in a predictable manner, so you can make mutations to this state in a predictable way. Okay, so Redux, taking inspiration from the Redux Flux architecture, as well as the way that Flux architecture works is by putting all of this store of your data, but Redux say no, let's gonna make all of this slice, all of these single stores into one big into one central store, right? Because here is much more easy to debug, to maintain, and when it comes to improve the developer experience, which is to know when a mutation happened given an action, which is part of the Flux architecture, we want to know from our DevTools how and when that happened. So the goal of the Redux is to make the state mutations predictable, all right? And for that, that's why now it set a constraints like immutability and serializability. So immutability, it doesn't mean what you think it is, which is not that the state is static, that it won't change. In fact, in software, immutability, we can start is by talking is the what we really need of immutability. So what are the things, what are the answers that immutability, or what is the problem that immutability solves here in software, right? Because at the end of the day, when you want to mutate your state, okay, it can happen is by assignment or by value. So by assignment is that when we use const, I will argue that here const is something that most of the time, if you follow functional programming practice, you rarely fall into these particular issues. I don't say you, I'm not saying that you never do that, but it is very less likely to actually have that kind of problem. However, when it comes to value, which is portable, it can be in different places in your applications, right? The thing here is you can have this value here in one piece of your applications, and then move on, navigate to a third-party library, come back and be again in another model of your app. And because of this, this functional programming, one of the things that it does is to try to identify where a bug will happen and avoid it by applying pattern where they can never exist. Which means is, well, let's go to now follow some practice here to actually know or notify to the author or the consumer or the user, hey, this data that we are using, that we're passing, is read only, right? Please don't mutate that. You won't mutate that. So that's why we use object.freeze, when you're gonna pass that to a function as a way to notify that, hey, this particular data is read only. And also another practice is that when you're writing your functions, you're gonna get that arguments, and always create is a read state from that, or create a new object from that. So assume that the argument that you're receiving is read only, and then work on that. So all of these things is just when you need to make your state read only. However, what happens when you need mutable? What happens when you need a mutable state to be immutable, right? I'm gonna say that again because it can become quite confusing. What happens when you need a mutable state needs to be immutable? Because at the end of the day, immutability in this context, it doesn't mean that the change won't, that the state won't change, that the value won't change. In fact, we need to know a way of how that change happens in a predictable way, so we can know what's going on. So that's why now the immutable data, which is needed change, needs to occur with intent. This is now a layer of control mechanism. This is a control layer mechanism where your mutations, or where your state cannot be mutated in an unexpected way. So that's why we have, for example, here libraries from the folks of Facebook, like immutable.js. Okay, so you have now a immutable.js is one of them here. The other is what now it provides is so it makes a wrapper of some of the data structure that you're familiar with, arrays and objects, right? And then provide now a layer of how you're going to update your state. So you can look at now is at all of this particular state being updated, and the way how that works is pretty much like Git. So when you now put all of this Git stories, or all of this So Git works by storing is the diff and apply that to the previous one, right? So this is pretty much what at least in immutable is working. When you have now, anytime you mutate the state, what it's doing is creating a new object with this new informations and internally pointing back to the previous one. So that's what it's doing behind the scene. And in having this understanding, which is perhaps they're using linked list for that, or they're using is the object.create as well, the part of the prototype inheritance, as a way to make all of this state mutations not only predictable but trackable. Okay. So why this is important? Because we were talking about immutability as well as serializability, which means is that we need that our data be in a particular format as a way to now make some optimizations. So that's why also one of the goal of Redux is to let's make all the update logic, or let's make all the state mutations or the state update logic synchronous. And this update logic will be done by a reducer, but make all of this state update logic synchronous. And if you need a synchronous behavior, you're gonna keep that separate from the act of updating that state, which means is that we're gonna put that in a middleware or some that kind of stuff. And well, by having one single root reducer here, and by having one single root reducers, we can make all of this reducer, all of these update logic functions. By having all of this updater, by having a single root reducers, where we can now compose all of this update smaller update logic that allow to explicitly know how the data is being handled, okay, and including dependencies or injecting dependencies, ordering when updating one slide of a state requires another slice. So the idea here is that with this set of reducers, we can now, of course, explicitly control how the data is handled, how the data is mutated per state. So this is now the Redux implementation goals. And when it comes to look at the design and intent, is that make the state manage. So it takes influence from the Flux architecture, and the state updates must be maintainable. As the top priority of this must be, the top priority of this library is that state must be maintainable, as well as to use actions story. So action history should have now semantic meaning. So all of these actions that are happening that will run your reducers, your update logic, must have semantic meanings. And also is now introducing you to functional programming, which is not a trivial thing here. Introduction to functional programming is like immutability, pure functions, and also talk about is the monads and end of functors. But the goal here is doing that slowly but progressively, while having a testable code, having everything organized by state or by slice, all right, where this particular slice will indicate how the data is updated. In this updated data, data flow is explicit, right? The updated logic there is explicit, and by having a Redux API minimal and extensible, we can achieve this sustainable. We can make the state management updates maintainable. So as a way to now have a more hands-on approach of this, okay, yesterday we looked at how can we use this Redux, okay, and starting to see what are the APIs that Redux has behind the scenes, where you have now the compose as a way to now run all of these functions after one another, okay, how we can create our store, right, like this. What are now the things that this store is creating behind the scenes for us, okay? How can we create our reducer, which is the updated logic, as well as our initial state and the actions, and how lengthy and verbose is any time, and how lengthy, verbose, and error prone is for you to create these actions. So in this case, it's like these two, all right? But if you, for example, misspell a particular actions, that's something that is you want to remove that out of the table. So how they do this? By now following is this create actions, which is using the Flux architecture or the Flux actions conventions as a way to have this particular object that is going to indicate all the necessary data, usually type and payload, but also containing its error and meta, that is going to now indicate which actions you are which actions wants to update the state of your application, okay, which action wants to mutate your state, and the proper reducer that is gonna do that. So this store now provides you this particularly convenience functions, okay. For example, here we can see that it provides you now the dispatch, get state, replace reducer, and subscribe, all right. And as you can see, dispatch is going to call these actions that you are passing to your reducer, similar to get state, and replace reducer, which is, yeah, it's going to replace the current reducer. So if you're triggering that as a way to get is the new update logic, because that's what it means behind the scene. Is like, hey, you're gonna get this new updated logic anytime you run this function, and getting this new update logic anytime that you need to, anytime that you call it, you essentially are gonna get is this new update way of updating your state, which means it's useful for code splitting. And then you have the subscribe. It means that, hey, this particular functions that I want to run, or React components, or something that we're going to see that later, but this React components or functions, okay, when I call a particular function called render, I want you to now subscribe these functions to whenever the state update. So here the following is now the observer design pattern, which is pretty much like what the node is doing behind the scenes, right? The observer design pattern. All right. So next, well, let's get into this.
Plus sign the value. We swapped it. Initially bring this up, but we saw that if you mutate an object, it is very hard for JavaScript to know that it changed and it's a new value, which makes React very sad. So a lot of times you notice that we didn't just like, plus sign the value. We swapped it out with a brand new object with a brand new number. The other one is we have that return state at the bottom. If none of those conditionals are hit, we still need to return something. That's just a JavaScript function. But to kind of look at that question is, let's say I had a deeply nested object, right? So here we've got an angry blog post that I wrote, and it's got a title, and content, and author. Those are all pretty easy to change in one reducer. You can have update title as an action type, update content as an action type, update author gets a little tricky, right? Because what if I want to just update the location that I'm in? Well, I have to kind of, and this was worse before ES6, right? ES6, I had to either use like object.assign or build new objects with a for loop or so on and so forth, right? But I have to make sure that I'm constantly spreading each part as I navigate down the object, right? And so this is kind of towards the question that Mohammed asked me, which is, what do you do in this case? Well, there's nothing stopping you from being able to either, when you create the state, to aim for the flattest possible option, or kind of break it down to reducers, where you might have a location that just points to a number that's in a different piece of the state that just manages all the locations. We'll actually see that in a later example as well. Mark.
Does it ever make sense to have multiple stores?
No, it's actually an anti-pattern to have multiple stores, right? There's
doesn't give any sense to have multiple stores.
usually one provider, and there are some like deep level kind of hooks if you're trying to create a third-party library that might use Redux that doesn't want to clash with the other one. But generally speaking, you'll have one store, and you'll just kind of have one giant set of your data. And there's some reasons why this is actually helpful on top of it, just because they said it was an anti-pattern, right? Having your state split between multiple stores means that kind of like what it takes to put your app in that, not to overuse the word state, is now split up. Right? Having one JavaScript object that represents a state, we'll actually see this in the Redux DevTools. You can then, let's say if a customer has a problem, they got themselves in some weird state. You can actually serialize the entire state of the application, get it as a JSON object, and then load it in development and work with it. Right? So having everything in one store is both practical for debugging, but also becomes problematic with like different stores clashing with each other. Like the React Redux tools is expecting like one context that is threads throughout, so on and so forth. Right? Otherwise, like use reducer will get very confused, or use selector and use dispatch will get very confused, so on and so forth. So generally speaking, one store, but we might split up into many reducers. Question.
Yeah, let's say I had a question. So if you have like a deeply nested object that you're getting from like your backend or whatever, and say you have to mutate it right in your Redux store at some point over time, would you recommend breaking that hierarchy into like a flatter structure when storing it in your store?
Absolutely. So the question was like, let's say I don't control the API and I'm getting a deeply nested object from the API, but I have to manage it on the client side. Right? For that, actually, we do this in some of the applications I've worked on at Twilio, where we'll have, at the API layer, we're making the requests. We will say, neat, this is what the API gave me. We will translate it into a flatter structure that works really well for the way that we see both, because the UI might be very different than the API, right? Like a lot of times, like we use our public APIs, which some of them were initially developed for the, on the SendGrid side for sending emails and being used server side. They're not necessarily built to build our UIs. But sometimes like you don't totally control the API. So what we'll do is as the JSON payload comes in from the server, we will reformat as we need it, and as we make the post request, we'll have a layer that just translates it back and forth each way, so that we have the state that works the way that we want it to. The other really great advantage of that is if the API changes, you don't have to go everywhere that was relying on the structure to be shaped like that. You change it where you're doing the translation from the API and to the API. You tweak it so it's going back to what your UI expects, and it's a lot easier to work with as one function.
So, in other words, so these reducers or this updated logic here have some rules, right? This updated logic has some rules, and it has some rules. Okay. And this has some and this has some rules. Oh my god. And this has some rules because updating your state, okay, and it has some rules because updating your state is all right. Yeah, and it has some rules, all right, because updating your states, updating your state logic, which is after all an object, it's something that you need to do that. You need to carefully do that, right? So because the idea is that you want us to return is a new state out of that, and doing that in JavaScript is back in the old days is something that is quite lengthy and verbose. All right. So returning, so mutating mutating a single property on a flat object is something that is easy to do, right? So if you have now, however, if you want to update your if you want to update city in this example, you will have to navigate down there, all right? However, if you want to update the city in this example, you will have to navigate down there and copy all of the other properties, okay, and copy all of the other property, exactly, and copy all of the, so you'll have to navigate and copy down all the other properties, right? So back then we use object.assign. So luckily now the language allows to do that in a more descriptive way using the spread operator. So yeah, right? So spread operator or spread syntax, right? Which is quite convenient here. So yes, one of the recommendations back then All right. So for example, now doing is this. So I have the experience of doing that in that order. All right. Prefer flat objects like this. And then, all right. And then, one of the tips here. So tips, right? Getting backend data, getting nested deeply backend data. It is recommended to transform, to parse that data into a flat, okay, into a flat object here. Exactly, parse that data into a flat object relevant to the UI. It makes a ton of sense. And when you need to post, when you need to post to backend, when you need to do a post, send it as expected, right? So you also have another layer as well. So right, so far so good. No problem on that.
All right, we covered most of the major surface area of the store, which, we saw that get state, gets the state, replace reducer, swaps out the reducer, dispatch sends actions into the reducer to do battle with the current state of the application. We have one more, and that is subscribe. If you've ever used like an event listener on the DOM or event emitter in Node, it's basically a way to say, I care every time the state changes. Here is a function that I will give you to go ahead, please call this function every time the state changes. So we can go ahead and...
Exactly. So subscribing here is pretty much like an event listener, on the DOM. It is pretty much like the event listener on the DOM, where the idea is whenever a state change, those functions, whenever they state change,
like an event listener on the DOM or event emitter in Node.
Or event emitter in Node, exactly. It's pretty much like the event listener on the DOM or the event emitter on Node, exactly.
It's basically a way to say, I care every time the state changes. Here is a function that I will give you to go ahead, please call this function every time the state changes.
Exactly. So whenever the state change, please call this function that I give you.
So we can go ahead and we'll make a subscriber.
Create a subscriber.
And a subscriber is going to be a function, and it'll just console log subscriber, and we'll do store.getState. And we'll call the value as well, or we can do the whole object. So we'll put that there, and now instead of using this console log here, what we'll do is we'll say store.subscribe.
Exactly, store.subscribe.
Subscribe, and we'll give it the subscriber. And you can kind of see code sandbox.
It's like, hey, I want you to now run this function.
This is loading a few times here, but we add a space. It gets loaded. We call increment twice. It's loading each time. I can say like add 1000, and you can see that every time the state changes, then all of a sudden we call that function. Why could this be useful? I don't know, let's say you're building a React application, you want to pass new props every time the state changes. Cool, React Redux can subscribe to the store, and we might have different mechanisms, whether the hooks or the connect API, to figure out what props a given React component needs, and we'd be like, cool, the state changed, neat, here's what that means for the props for these components, let's pass in new props and keep everything up to date. So at this point, we've got the entire Redux store pretty much covered. Right? We do have a few more of those helper methods to look at. One is this bind action creators that we can kind of pull in. And we saw that an action creator is either one of these functions. They are simply functions that create actions.
So let's go to make this now subscriber. Here we can create subscribers. Okay, which is, hey, this is the subscriber, where this is a function they're gonna give you to, similar to the events handling, the event listener on the DOM or the event emitter in Nodes. Like, hey, here's the functions that I want you to run whenever the state change. In this case is, well, whenever the state change, I want you to now do this. It's like, hey, please, right, make this things, which is console log. Where are you looking right now? Oh, that's right. Which is console log, right? Say, hey, subscribe. It says we're triggering subscribe. Okay, and then call that state store, in this case store dot get state as it is, right? So anytime we actually is dispatch now a new actions here, let's say in this case, hey, incremented, but I want us to now say, hey, add with 1100. All right, now we want to take a look at this. When we reload it, we'll now be able to reload this. All right, we'll now be able to actually is, because we haven't subscribed that to our store, that's what happened. That's one of the reasons why it's not getting triggered. So you say, hey, I want to make to this store subscribe this subscriber, right? As it is. So good. We're passing that as a reference, so behind the scene is going to call that function. All right, that is of course going to trigger whenever the state change, right? Because of course we register that after, well, it's actually doing that. But all we can do is we can subscribe this. In this case, yeah, dispatch 100. You can say, hey, let's go to now call this the increment. All right, here the increment, which is now an action. Do I have that? Store dispatch is increment action. That's right. Okay. And when we reload this, oh my god, no, Mother Nature is calling. So you can see actually that is changing as expected, right? So we subscribe to those changes. So we're back. Oh, Mother Nature called. Woo. And then the other is binding action creators. All right. Binding action creators. So let me actually show that. Which is this? Subscriber and binding actions creators. And now that it makes a lot of sense when we do that, right? It makes a lot of sense. It makes a lot of sense. Okay, this is now the example. It makes a lot of sense.
Seems legitimate. And so bind action creators just gives us a way to do some shorthand. Here we kept having to say store dispatch increment, add 1,000. What if we just wanted to make functions that were bound to the dispatch that we could just call? And that's where bind action creators comes in. So we could say something const actions.
What will happen if we were to have bind actions?
What if we just wanted to make functions that were bound to the dispatch that we could just call?
Mm-hmm. So what will...
So shorthand. Here we kept having to say store dispatch increment, add 1,000. What if we just wanted to make functions that were bound to the dispatch that we could just call?
Okay. So yeah, so because we are calling dispatch several times for triggering the action, the action that we want, what if we call the dispatch action, the dispatch function, with our proper actions? Okay, so without actually doing that.
And that's where bind action creators comes in. So we could say something const actions, and that could be bind action creators. I'm going to turn off this. Let's get rid of that as well, so we don't keep seeing that in the console. All right, so we can say bind action creators. We can give it some actions. We can say increment, add. We're just putting them in an object. And if we look, we console log actions now. We can see that we have an object that has the keys that we passed in plus functions, but these are automatically called dispatch. So we can.
So makes sense. So now instead of actually doing is this, all right, that we have all of our actions, bind actions, okay, bind actions creator, okay, as a way to combine or as a way to trigger an action with a proper, as a way to trigger an action with a proper, as a way to trigger an action with the proper, as a way to trigger a dispatch, because it's that, as a way to trigger a dispatch with a trigger dispatch with the proper action. So we bind them all into a hash, okay? So we bind them we bind all of them into an object, okay, which is a record here. That's why this, when you say store dot bind actions creator, is like, hey, give me all of this actions creator here, and it say give me the actions creator here, where now C here is this action creator do something, actions creator this, actions creator M, followed by the dispatch, and actions creator here. So, but the thing here is that an object whose values are actions creator function. One handy way to obtain is to use it EX6 import all as syntax. You may also pass a single function. So here you're passing is all of this as an object by saying increment actions and add, increment actions and add. All right. And if you want to know what is the output of this store binding actions, oh, but it actually provides you, okay. Oh, instead of okay, yeah, this is also that is provided by Redux. Okay, so Redux provide is this. It provides you the create, store, compose, bind actions creator as a way to say, hey, all of these actions here, which is the actions here, all right. Now I want to look at them and see that we have now is one single function here. So the exactly, because the actions creator here must follow that particular format, must follow that, must follow that, must follow that, and I don't have that, as you can see. But exactly they are must follow is this function. Exactly. Okay, because creating all of these functions here like that, because creating all of these actions that is going to return now the set of actions that we can do to our state that is being used by the reducer, this update logic, to determine what to do when a particular action needs to happen. Okay, needs to occur, in this case increment. Okay, that's right, in this case increment. Okay, and when you now pass the increment, which is this function that is binding all of this into one single object. Why this is useful? You know, why this such things is useful? You already have all of these actions now in it, so you keep track of all of these actions here, okay, like this. So you keep track all of these actions here, and any time the update logic needs to so what you're doing here is to have a record of all of these actions. So useful when you want to trigger that action. Useful when you want to trigger an action, keep track when that function was called, and therefore showing you the action history for that. So hey, we are updating this particular state, this action was triggered, and therefore you can see that in the DevTool.
There we go. So just JavaScript at that point. Made some small boo-boos there, which is bind. Let's just review this for a second. Bind action creators takes an object full of functions with keys and values, and gives you whatever you want to bind them to. And now instead of saying dispatch and having to call the function, just they're put onto this JavaScript object. If they didn't have the same name, I could also separate them out as well. And now just calling the function automatically takes the action creator and passes it to dispatch.
So the thing here is that not only look at this, okay, but it's from this particular actions here. Now you can call that you can call that relevant actions here. So instead of actually you having to call the dispatch, so you of course so we're lazy when you need to write it down. So we say, hey, actions, right? I want you to now call the increment. All right. But this action, okay, is like, hey, I want you to now call is this binding action creators. And then you have now the actions to add. You say, hey, 100, right? So if you're gonna get the state from that store,
if you really want it,
you can also say store dot get state for that. So it's a now actions dot increment here, increment here. It's a dispatch, is not a function. Okay, makes sense. That's why interesting. Dispatch is not a function. So we somehow need to attach that. Exactly, we somehow needs to attach that, and that's what it say. Hey, attach. Okay, we need to exactly makes sense. Binding action creator, that makes a lot of sense. Is bind actions creator is a hey, all of these actions that you can do, all right, as a way to as all of these actions that you can do as a way to update the state by applying a reducer, where each one of the reducers is going to check if all of these actions is going to check what to do when this action is triggering. Okay, that's what you need to bind it to the dispatch. Makes sense. So the store that you create to dispatch. All right. So now it makes a ton of sense, because now actions say, of course, now I have the reference of this object, okay, and because I'm binding this particular store, this dispatch method from this store that you create from this, from this store global state, now I can actually call that. Call those actions. You see? So actions.increment, action.add, 100, and so on and so forth. So that's great. That's powerful.
Gives you whatever you want to bind them to. And now instead of saying dispatch and having to call the function, just they're put onto this JavaScript object. If they didn't have the same name, I could also separate them out as well. And now just calling the function automatically takes the action creator and passes it to dispatch. If you really wanted to, if bind action creators wasn't in there for some reason, and you really wanted to write it yourself, this kind of goes back to that answer from before that we saw. It's very similar and probably under the hood, just using let's give it just new names for a second, where we could say something along the lines of compose store.dispatch. And we can make either one of them using compose. Let's do that real quick. Right, because we saw before that we take the value of the first object, which is the action we get, we're immediately passing it to dispatch. Right, and so if I wanted to do a bunch of them, as we saw before, I could just simply take increment,
exactly,
and add, and map through them.
And map to them
and just
for the function, and then you compose it when this function is a way to call each one.
Store.dispatch. whatever the function was, right? This is a very simple version of what bind action creators is doing for us, but we don't have to do this.
So, if you want to know underneath the okay, so underneath the hood, so underneath the hood, underneath the hood, create binding action. What it's doing is to say, hey, let me actually now pass all of this function that I'm receiving. Okay, dispatch increment and dispatch add, exactly. So dispatch increment and dispatch add, all right. And then I want you to map I want you to I want to map is okay, I want you to map that from the store dot dispatch, but the store dot dispatch, or in this case is from the function that I'm getting here, which is the increment and add, map then, all right, and now call those functions here in this particular order. No, and then call this function is now call this particular function here. So what it's doing is to say, hey, because behind the scenes you already have this increment and add functions, all right? I want you to now map to each one of them and then call the compose. And the compose is just a function that what it does is to allow us to call functions one each another, right? To call function in this particular order. Hey, I want you to call this function for this. Hey, I want you to call this function for this. And after that, you're gonna create now is a function. Okay, and after that, you're gonna create now is a collection. All right, it's an array where you're going to assign to each one of these actions with the proper function. Binding actions creator. So we can think that bind actions creators behind the scenes is getting or mapping through all the functions we pass to them. Okay. Map through all the function we pass them, and compose is gonna call that, because compose what it's doing is that, and compose is returning as a function for that. Exactly. And compose is returning is a function from that you can call that. In this case, only one. Exactly. And give and assign, right? And assign, exactly. And assign this, and assign such function with compose to a collection of dispatch actions. So this is what we can think that is doing behind the scenes, right? Because at the end of the day, if you want to actually map that actions that if you want to map all of these actions that you're passing here, if you want to map is all of this function that you're passing here to that dispatch, all right? So behind the scenes, what it's doing is that I'm going to now is all of this dispatch that you pass me here, all of this name that you pass me here, all of this function here that are now the dispatch, you're gonna append some dispatch name to that, and also followed by the name you provide me, okay? And then internally, I'm going to iterate through all of these keys of function that you provide me, okay? All of these functions that you provide me, compose them. In other words, means that return you now a function that is going to be tied to the series of dispatch in that position, in that element. Damn, son. Even though I don't even understand that, but to make it simple is that because what it's doing is to bind create actions, okay? Binding actions creator is like, we know that the action is a type of objects. And as a way to make this much more simple to work and to test, we create a function. So this function is something that we're gonna pass that to this function called bind actions creator. And in this case, we're passing is increment and add. So behind the scenes is getting this actions and bind them to the dispatch. In other words, is that it can have is it's going to now map first through all of these elements that we are. It's going to map through all of these action functions that we pass, and then compose it, which means that wrap them into a function that will be called, and then assign them to the proper dispatch name into a collections. Makes a lot of sense. Binding Jesus, binding all of the things that you provide me to something that internally I use, binding all of these actions, functions, and we're passing action function because it's easy to test, to with the compose, and then create those dispatch, and then assign the dispatch followed by the name of the function, so you can now actually dispatch the proper function for that. Holy hell.
Because it is, again, one more of those little helper methods that are available to us on React. And we'll even see that we can use this, it's on Redux rather, we'll see that we can use this by ourselves, but also things in React Redux, a few places, will be able to kind of use this for us under the hood and give us different functions that we can call that can immediately talk to the store in some very simplified use cases. Right, so it's also used under the hood with Boot.
Exactly, it's like, it is tied in, it's like the compose here. So the compose here is going to tie that to the store.dispatch. Exactly. I want you to now is, that makes a lot of sense. I want you to now run this function first and then this function. In this case, no, because it's I want you to run this function first and then this one. That's the order, from left to right. So if we take a look at the compose here, okay. Wow, this is jargon. This is arcane stuff. Compose in Redux, that's right. Each function is expected to set a simple parameter. Its return value will be provided as the argument to the function standing to the left. Okay. Okay, it is value. Okay, it is returning value. Okay, it is returning value will be provided to the element. Okay, which means is that it's gonna call the last here. You're gonna call is the last here, and then that will be served as the argument of this. So you're gonna call this. So the return value, which is after all is this action creator. So the return value will be act as the input of the function of the left, right? As an argument to the function standing to the left, and so on. The return value will be provided as an argument to the function standing of the left. Okay, so the return value, in this case by calling this, will be provided as the argument for this function. Really? The section is the rightmost argument, which can accept multiple arguments, as will provide the signature for the resulting compose function. The final function obtained by composing the given functions from right to left. But it's from right to left. Exactly. Hey, I'm calling this function from right to left. I'm gonna call this function, and that will be now the input. So the result of this will be the input of the. So the result of this function will be the argument of the function of the left. So when you call this patch, okay, now this will act as the input of the store. This will act as the input of the store. Okay. Well. All right.
With a few libraries as well. The question was, when we have the subscriber, actually we can see it right here, how do we know what values have changed? You don't necessarily know which exact values have changed. You can get the entire state that's within the store, right? Now, the closer you're using the primitives, like strings and values and boolean, strings and numbers and booleans, the easier it is to see are they different, so on and so forth, right? One of the things that we want to do when we're manipulating the state, which is, I kind of said this in that slide earlier, which is if you change it, you replace it. However, that doesn't mean you need to change every object that you're not touching, right? A lot of times we want to make sure that, like, or if we don't necessarily add something to an array or change a property on an object, we can return the same object, which means they're going to be referentially equal in JavaScript. But in the actual subscriber, we'll get the entire new object. The parts that have changed will be referentially different because we replaced them, and the parts that haven't changed will equal their previous versions as well. So when we take pieces of that state tree and we pass it into our React components, either React itself can be like, okay, cool, the number for our counter was 2. If it was also 2 last time, it hasn't changed, don't re-render the component. Okay, it's now 3, I should re-render the component itself. So as we begin to break stuff up, React will actually handle a lot of that for us, so we don't necessarily need to worry about it too much. Okay, so at this point, we've got about 60% of the Redux API covered. We've got bind action creators, which kind of just uses compose.
Exactly, bind action creator, we're kind of actually using compose for that. Okay, that makes a lot of sense. Exactly, that makes a lot of sense. So store dispatch and the function is that it's gonna call this, all right, and the input you're gonna call from right to left, and now that the outcome of this will be the input of whatever is on the left side. Makes a lot of sense. Now it is. Now we're talking.
Compose takes multiple functions and creates new functions out of them. We got create store, which is arguably the most important part of the API.
Okay, so we have now the compose, right? As a way to how you can now is calling these functions in a particular order. You also have now is the bind actions creator as a way to get now all of these functions that are good, as a way to get all of these actions functions that is following is the flux actions conventions to notify is when an action happens, okay? And that internally, what it's going to do is to now map to all of the actions function that you pass, all right? And then call them with the compose by saying, hey, that function, I want you to now bind that. So the return of that functions that you pass me from of the create action, I want you to make now the input of the store dispatch, right? Run the store dispatch that now will have this particular name. So in other words, let's say you are passing now the increment and the add function action construct function actions, which means is that I'm going to iterate through each one of them, and then I'm going to now call the compose as a way to say, hey, let's going to call this increment actions functions that is going to return is this action object, following is the flux architecture notation, flux actions notations, that object will be the input of the store dispatch. So the store dispatch was behind the scene is like, okay, so let me now attach, all right, behind the scenes, the dispatch and putting a name to that, so you can now have access to this. So this is a piece of wonder. It's a very mechanical stuff here that actually is doing a lot of things for that. It's involving pure functions and mathematical concepts, especially when it comes to work with functions, something that is hugely in demand.
And it itself had 4 methods. It was 60% of the way through. And if you think about actual complexity, we're really a lot closer to understanding all that there is to Redux. Applying it will bring up some new challenges that we'll have to work through. But Redux itself is just objects and functions. So let's look at combine reducers. And I kind of alluded to this earlier, and there was a question around this as well. As the state gets a little bit more complicated, changing this stuff can be a little bit harder as well. So go ahead, let's clear out some of this. Let's say we had an initial state where we had, I don't know, like a to-do list where we might assign stuff to different users. So our initial state could have users, and we'll give it like an ID of 1. The ID of 2, we'll give the name. Can't see the names on this. I can see Eric. Oh, yep, that's an object as well. You gotta wrap these each in an object. Great. And then we'll have tasks, which will have, I don't know, a title. And we'll say, order more Monster Energy drinks. They're not sponsoring, so they don't get mentioned. Order more energy drinks, right? And as we saw before, if we just wanted to change like user number 2's name, we would have to kind of like start dropping through this object, spreading as we went along. This could get a little bit more complicated. One of the things that I recommended in that slide earlier was to go ahead and figure out, can we make stuff flatter? I'll kind of just pull in what the kind of more complicated reducer would look like, and then we will simplify it a little bit as well. So let's pull it in and we'll kind of talk through it. We'll add these. So if we look, we've got two action types, which is add a user and add a task. The payload is going to be the title of the task, the name of the user. We could theoretically just make, we didn't have to nest them in objects per se. In fact, let's not. But you can see as this object grows, we'd have to spread out the state and just replace the user array, but then take everything else that's in the user array and just add the additional payload on there. You can imagine, we saw this in that slide before, that this grows over time. This is a relatively simple application, and it's already getting tedious. I saw like when I showed that slide when we had the location.
Okay.
Being the city being nested under location, being nested under author, and we show the number of spreads, like a bunch of your eyes like got very wide, right? You're like, do not want, absolutely not, right? And so if you find yourself doing this, right, it is time to think about whether or not either A, as the question I saw before, which is, do I need to change the shape of the state on the way in, or do I need to split this up between multiple reducers? And one way to think about that is like, what are the nouns in this case? Well, you know, changing the shape of the API, if it is like one kind of thing, like there are times for performance reasons, you might even want to split out one object, like one model as multiple reducers. If you're only changing, let's say, the title all the time, but the rest doesn't change, right? You can do it for performance reasons. But in this case, like we have two distinct things that we're working with in this case. And it would be nice if we just kind of split these out into two smaller reducers. Now, if you saw before, create store only takes one reducer. So this is all kind of like smoke and mirrors. combineReducer just basically makes one reducer out of a bunch of small ones that we can eventually hand to create store. So how would we refactor this? Well, we could say that this seems like one distinct thing that we're doing with users. This is one distinct thing that we're doing with tasks. So what if we actually said, up here we'll say const
Again, this is another example, right?
user reducer, and that is going to take state, which is going to start out
so
as
all of
initial
this
state
update logic
users
must be relevant,
and some action.
All of this update logic,
And this is why
again,
I like to use the initial state as the default prop to each reducer, because I can just pull in what I need rather than having one master initial state somewhere else. So you can imagine, like, as this grew, that object would get very big for that initial state. I like to just kind of break it up with the reducer that's using it. So we have the user reducer, which is going to take the state, which is the users on that larger object, and some action. We can just pull this in. And we're going to have to refactor it slightly. If I make a boo-boo, someone notice. So we've got the add user, and now really it's just the actual users. Great. And we can do something similar here. So we don't want to say dot users. Now it's one thing we could do here, since we know it's just users, since this is just a variable, let's just make our lives easier and call it users. And for the task reducer, we'll say tasks, initial state dot tasks, and the action. And we'll pull in this code right here.
Hey, you're missing a...
And now this is simply this array. That. And so we've made each one of these reducers way simpler, and now we're going to get effectively the same result by making what our reducer, we'll just say combine reducers, and we're going to say that the users part of the tree is going to use user reducer, and the tasks part of the tree is going to use the task reducer. These are all single. So if you think about the shape of the object in the initial state, right, we had users and tasks, right? And so we're basically providing that same shape to what combineReducers gets. So instead of having one that took the entire object, it's going to be like, cool, I'm going to create a reducer that for this section of the tree, for users, it's going to use a user reducer, and for tasks, it's going to use a task reducer. Right? So you're basically defining what reducer should be used on this larger state tree and breaking it up into smaller pieces. So
can it be more nested, like user dot
yeah. You can. It's basically you're just kind of mapping it to the shape of your state. It can be as nested as you need. Now, clearly, the further you nest, the more complicated it's going to get. So the advice that I would give in that sense is as much as you need to and as little as you can get away with. Right. The flatter your object is,
as much as you need to and as little as you can get away with it. As much as you need, and as little as you can get with it. Okay, but the thing here, okay, it's like exactly the idea here is that not overcomplicating the stuff here. With this combineReducer, it's just because remember that at the end of the day, this reducer, which is just updating logic, you want this to make them relevant to update that particular state. Okay. Remember, the idea here is to make all of those update logic flat as possible, easy to work, single responsibility. That's what it's doing behind the scenes with this combineReducer, is that mapping that reducer with a state.
Defining what reducer should be used on this larger state tree and breaking it.
The pattern here is mapping, bro. The pattern here is mapping. Mapping sequence, mapping objects and functions. Interesting.
up into smaller pieces. So
Can
there's-
be more nested, like user dot Indian user.
yeah, you can. It's basically you're just kind of mapping it to the shape of your state.
Exactly. So combineReducer, what it's doing is mapping your update logic, the reducer, to the relevant state. Very important. Why we want to do that? Why we want to do that, right? Easy to test. Okay. It's easy to test. All right. To debug and maintain. Right? My 3 favorite things: easy to test, debug, and maintain. Holy hell.
It can be as nested as you need. Now, clearly, the further you nest, the more complicated it's going to get. So the advice that I would give in that sense is as much as you need to and as little as you can get away with. Right? The flatter your object is, the easier it's going to be. Because imagine, could you continue to nest combine reducers? Yes. However, when you get that entire state object back, guess who's responsible now for navigating down that entire tree to get to the piece of data that they need? Right? The flatter you can keep the object, the easier it is for both storing data as well as getting the data back out. Right? It might make sense in your UI that maybe all this stuff is nested, but a lot of times keeping that stuff as flat as you can get away with, that's as much as you need to and as little as you can get away
separation of concern. One of the components of
Right,
a
so we've got a
well-architected
reducer here.
UI is not only
But
test,
they still have their
build,
own.
and the static systems, but also is to now
What's the issue here?
encapsulate
token.
or separate the which is just abstraction is just a fancy way to say separate.
Where's that? Oh.
So separate the update logic
Perfect.
of or the
So now the
business
store,
logic
we
from
wanna
the
say-
UI logic.
Console log. Define string during initialization. Reducer users returned undefined during initialization. State passwords reducer is undefined. Oh, I broke one of my cardinal rules from before. Does anyone see what rule?
Error reducer user return undefined during initialization. Return the initial state. You must return the initial. If you don't want to set a value for this reduction, you can use null instead of undefined. Instead of the reducer, error reducer users. User returning. Oh, I get it. No, I get it. Yeah, you need to put at the last is the state.
You're
Yeah.
not returning default. So when we started off, we said
Yeah, you're not
that by
returning the
default
default.
it's going to return the state that gets passed to it. You're
Yep.
not returning
Exactly.
the default
Yeah,
state. So
exactly.
if the if statement was not being
It
run,
is
you're not
expected.
returning the state
Exactly.
that gets passed to it. You're
Yep.
not returning
Exactly.
the default state. So if the if statement was not being
If the
run,
statement was not wrong, you're not returning.
Exactly.
like
Right.
that.
In the case that we don't hit the conditional, this function returns undefined. So we need to make sure that we return, in this case, users,
The users.
and in the other case,
In the other
tasks.
case, use a task for that.
Cool. And then I got to finish typing the word console log. Console log, and this one we'll do store.get state.
Get state.
And you can see that I have the same basic shape to my state as I had before, even though I split it up, right? And so now, the really interesting thing about this is, and one of the things I really love about the way that the Redux implementation works, is all of the actions, whether they are add task or add user, will flow through every combined reducer. So for instance, if it's like add task to user, both of those smaller reducers will get the action, so you can both kind of handle it separately. You might take like an assigned to property on the task and update it to point towards the user. You might take the task ID and put it on an array of tasks for the user as well. Right? Every action flows through every single reducer, which means to
Every action flows through every single reducer.
do
which
a thing, you don't have to like figure multiple actions to handle every single step that you need to do. You can fire one action and have that action flow through all of the combined reducers and be able to update the state accordingly. So it's very similar to having one giant reducer, but you won't end up being very displeased with yourself as your application grows. Great.
But what if same? But what if different users are changing the same property? It's not like the last one should be affected, right?
So the question was, what if different reducers change the same property? The great news is
The same property. It's not like the last one should be affected, right?
So the question was, what if different reducers change the same property? The great
What is different? Okay, what is different? Reducer change the same property.
Great news is that they can't. Because if you look at the user reducer, it only has access to the user's part of the state tree, right? And the tasks reducer only has access to the task part of the state tree. They basically taken our large state tree for our application and divided it up into a bunch of smaller pieces so that each one of these reducers handles its own little part of the tree. So they can't actually, two different reducers can't modify the same piece of state because they don't have.
So
We'll add these. So if we look, we've got two action types, which is add a user and add a task.
If I want to add that user here.
Just wanted to change like user number 2's name.
Okay, so screenshot here. Okay. Transcribe the JavaScript code from the image. Oh, lovely, bro. That's pornographic, bro. Okay. Here we are. Okay. Index.js, right? Okay, let's make define is now the reducer example. Yeah, combine reducer example. Combine reducer example. Where here, would you please create it? No? Okay. Since you're not. Reading combine reducer example, but yes. Why take you so long? Interesting. Combine reducers example. .js. That's right. Thank you. Much obliged. Much obliged. Okay. So the idea here, because you can have your reducer logic there, okay, I'm gonna save this, because you can have now your reducer logic here with combineReducer, which is part of the API. combineReducers here. Yeah, with combineReducers here, right? So what you can do is to say, hey, let's go to split this logic, all right, into their own reducer. So you have now the reducer for the user, reducer for the state, reducer for each particular state here. Or in this case, an update logic for this particular case. That's what happened. All right. Okay. this is just for demo purpose, but as you can see, this Reducer now change, now update, now mutates the state from, so now this Reducer now mutates two different states, which can be problematic. To solve this, we can use is combineReducer. Behind the scenes is mapping a reducer with a proper state. Okay, so what we can do here is to say, hey, let's go to create now the user reducer here. Okay, where here you're gonna receive is the state that'll be the initial state followed by the actions. Okay, and here you pretty much can say, hey, get me this use cases for the user example, and here we can only say is this, and we need to return now is what we need to return now is the users. So we need to make much more sense is the user followed by the action payload for that. And also, if there is no actions triggering this, okay, or if there is an invalid, when you're running this function and when you're passing an action that is not defined, please return now the users. And we're gonna do the same here, but for our task, right? Task reducer is another state where you say, hey, this will be the task in plural that we're gonna assign the initial state, but in this case from the task, and here we're going to assign is the initial state from the users, okay, followed by the action needed. And to handle now all of this update logic, all of these actions, all of this actions type, all of this state mutations here. So by having is this action type dot add task, that's right. In here we want is to now return is this collection, okay, in this case is the task followed by the patient action payload. And if we don't have any and if we're receiving is any and if we're receiving is an action that is not defined, please return now the task, the particular state, in this case the task, right? Return the task, and here is there is a missing here, and then last but not least, what you want to do is to combine that, combineReducer, which is user reducer. Well, I don't know, I'm assuming. Okay. This is an object, all right, that is say, hey, use reducer and the task reducer here for that.
Providing that same shape to what.
So this is our reducers here, right? So this is our reducer, exact.
Right, so you're basically defining what reducer should be used on this larger state.
So what you're doing exactly is to defining is that which reducer should you map to this user reducer, test and test reducer, because after all this is accepting this object with this key value here. And then we need to find a way of how we can add that to our store, all right? Which is reducer. Can you see what I'm doing right now? Is this one? The reducers, okay? And then how now I add that reducers to the create store, you know? Because after all, this store here from the create store, it say, hey, oh, provide me the reducers, all right? And the initial state, then you need an initial state, my friend. Store enhancer, and the preload state. Then you need a, because we're actually passing to that. Really? So when we're creating our actions here, we're just passing is the reducer or the initial value. Okay, so now when we actually say, hey, console log of this, let me actually put this as the, say intro Redux API, right? Then you have this the combined example reducer here. Please move that. Okay. And then when I want to get access to the store, let's say is the store reducers, right? Exactly, but you need to pass is the initial state. So in any case, let's go to define here is an index, say index.js, right? There really exists, wait, what? Index.js. What the French toast? Can I create that index.js? Right? Okay. Interesting. Okay. So let me rename this as the index.js, right? Oh, okay. Okay. Chill. What you doing? Or what you think you are doing? Makes sense. All right. And what we're gonna do is just to import the model from the combineReducer example, right? So I want you to now run all of this. Everything for that. So now it's a message is read only. Which message do you mean, bro? .js. All right. It's not. Why is not? Okay. No problem. Then you say here with the index, we'll now be able to see is that dispatch store as it is, right? You can of course have access to any of these internal methods, okay? But if you want to now get the value of that, we can say is store.getState from that. And now we're be able to look at that and see what's going on down there. There you got it. So that's task, and user, as you can see, is this.
Here. Just pass that in, so they'll have their own. What's the issue here? Unexpected token.
You're missing out that your recent user, I guess.
Where's that? Oh. Yep. Perfect. So now the store, we want to say console log, define string during initialization. Reduce, yeah, this user's implementation works is gross. The state tree. They basically taken our large.
Okay, good. Then we got the enhancers.
So at that point, we've got combined reducers, we've got bind action creators, we've got compose, we've got create store. We are down to the last and final method that is on Redux, which is apply middleware. Now, good news and bad news. Good news, it's the last one. Bad news is that there's one more thing that we have to learn about as we kind of get comfortable with this. So clear out some of this again for ourselves. So we'll create just a really quick reducer again. This is the simplest valid reducer. Is it takes the state of the world, it ignores the action, and gives you back the state of the world. It's a very stubborn reducer. So we can go ahead and create a store with this reducer. We saw that we could have some kind of initial state as the second argument. It also takes one more argument, which we'll see in a second, which is a store enhancer, which is a function. Okay. And we'll build an enhancer in a second, and you can actually pass this the second argument as well. The only required argument is the reducer function. Everything else here is optional. And an enhancer is basically, if we wanted to add additional functionality to a Redux store, this is a place where we can pass in a function, which will get an instance of create store, allow us to do whatever we want, and then pass all the arguments into it. Let's look at a quick diagram here. So we've got create store, it's got the reducer, it takes the initial state and the enhancer. What the enhancer will take is first, it's a curried function. It returns a function. It's going to take the copy of create store that we're calling and a copy of all of the arguments we handed to it. You can do whatever stuff that you need to do, and then actually call create store. To be clear, generally speaking, you probably won't write a lot of enhancers, right? Because you need a pretty good reason. The Redux DevTools are an enhancer, right? Because they're basically wrapping your create store with all the stuff that hooks it into the Chrome or Firefox DevTools, right? And so that's a use case for an enhancer. The other thing we kind of mentioned was apply middleware. The function apply middleware creates an enhancer that we'll see in a second. Well, let's actually look at the syntax here, because it's not as scary as it sounds. So I'm going to write one, and then you're going to write one, and then we will talk about it together as a team. So we can go ahead and let's say we want to have an enhancer that theoretically monitors, takes performance metrics of everything happening in Redux. That seems legitimate, right? So we could say, we'll call it monitor enhancer. And that's going to get a copy of the create store function that it'll be able to call later. And it's also going to get reducer, initial state, and enhancer. Cool. And what we'll be able to do is we will eventually you could go ahead and just immediately return. This is an enhancer that doesn't do anything. Initial state, and we'll call it immediately. But if you want to do stuff like wrap the reducer in another function that prepares it. So hypothetically, if we want to take a performance benchmark before we call the reducer, and then a performance benchmark after we call the reducer, console log it, we can do that here, and then pass that wrapped reducer to the actual create store. So we can go ahead and we'll say something like const start equals performance now, const end equals performance.now, and the diff we'll math that around it.
Math the round.
And so it'll be the difference between the end time and the start time. I'll leave this spell const right. And here we'll actually just say, well, we'll just call the reducer function because it's just a JavaScript function, right? We'll say state and action. Instead of state, we're going to say start down here. right. Oh, we gotta wrap this. Hold on. We need to we'll make a reducer. Hold on. We'll say replacement reducer. Well, we'll say monitor reducer. That is going to take state and action.
Okay.
It
Monitor
will
reducer.
pull all this in.
So it's gonna put all of this.
Call the real reducer once we've taken our performance metrics with state and action. And then return the new
And
state.
then we're gonna return this in your state from
Let's also console log that diff. Great. All right.
So
we've got
this is now
that
a
in place. This
monitoring
enhancer doesn't work here.
reducer,
This doesn't
monitoring
exist, so we'll replace this real
enhancer.
quick.
We're gonna pass
Now
this
we have
monitoring enhancer as a way to look at that.
Clear that out. Enhancer is not a function. Oh, we gotta pass in a monitor reducer as well.
Because you need is to pass.
Where's that other
It's
enhancer?
not an enhancer, it's not a function. Oh, because you're not using it.
This one doesn't exist. That's fine. All right, I need to quickly change
You
something
need
calling inside here.
to-
This is enhancer. And now we'll pass our new monitor enhancer into the real create
And
store.
then you're gonna pass this monitor enhancer to the real store. And this monitoring enhancer here, what you're gonna do is to check the updates
Perfect.
logic here.
So now we have one in place where we can dispatch some actions.
So when we dispatch,
Doesn't really matter
this,
since this reducer doesn't really do anything. And we can see, we'll actually just get rid of the rounding. You can see that now I'm logging the actual time it takes to run through the reducer every time. So this allows you to create like reusable plugins effectively for Redux that you can pass in there, and now it'll wrap every single call to the reducer in the performance metrics. So now they just pass this in. Same thing with the Redux DevTools, as we'll see before. You can pass in these enhancers. It will wrap and extend it almost like a plugin architecture for Redux as well. The question was, is the role of enhancer kind of a middleware? Yes is the answer. Apply middleware is the function we're going to take a look at in a second. Apply middleware takes a whole bunch of different middlewares and creates one composed enhancer out of all of that middleware. Enhancers themselves can be used for a lot of things. Adding middleware, using for the Redux DevTools, any kind of plugin that you want to do or functionality you need to add to Redux, enhancers are the way that you do that. So we're going to take a quick challenge break, which is I made one that monitors performance. Why don't you create one that simply console logs the state before we call the reducer, and then console logs it again afterwards, so that we can actually see before and after on every single action that flows through. Right? This is something you might want to like turn on in development. Now you don't have to add console logs all over your reducers. You make one enhancer. Every action that flows through will console log before we hit the reducer and after. So it'll be very similar to what we see in this monitor reducer, with a little bit different.
Interesting. So you can now, for example, is with this enhancer is to actually enhance the functionality of this Redux as a way to not only check the performance or to know when an actions happen, and to know when an action is dispatched, which is a great thing. Okay, and do other stuff as well. But this is widely used, for example, in DevTools. Holy moly, that'll be all for this video. Okay, so enhancers. Okay, we look at the actions creator. Okay, we look at the actions creator, setting the initial state, rules for reducers, subscribing bindings and combined reducers, followed by the enhancers as a way to understand that things more. That'll be all for this video. Take care. Bye bye.